You're going to be investigating and testing a series of 6 sealed tins. And all you have to do is work out what's inside each of the boxes.
It's definitely quite small.
Yeah.
Metallic? I think it sounds metallic. A paper clip or a safety pin.
Yeah. It's obviously lots of things.
Something packed in there.
It's packed in. Is it encapsulated in something inside as well? Not being able to open the box in science is essentially what happens every day in what we do.
Well, it's fairly heavy. Nothing is loose inside it.
Oh, it looks like
jelly,
like jelly or
solid.
something solid. I work with brains. I mean, I try to understand how the brain does science, and that's exactly a mystery box. I mean, we have specific techniques that we can use, and we're developing more and more techniques that allows us to get an insight.
Ooh. Sounds bouncy.
Yeah. There's one.
I think it's round.
I think it's quite big as well.
It's quite heavy. Plastic bands or bouncy ball? Bouncy ball.
All right. Bouncy ball.
Brilliant.
Sounds like it's
like
more than one thing.
Yeah, it's lots of things, isn't it? It sounds like sand in a bag. A bean bag or something like that.
My job now sort of is how to investigate how people have got disease, and also the other aspect of my job is finding out how people died. I've got such an inquisitive mind. I'm always asking questions: how, why, what. That's what I enjoy about pathology. The dead person can't tell me why they've died, so I have to find that out. Like a beanbag.
Like a beanbag juggling ball or something like that.
Time is up.
There we go, done.
What are some of the skills and processes that you've been using in that activity?
We had to listen very carefully to the behavior of the object in the box.
Okay,
so sensory information.
Whether it's heavy or light and how it moves in the tin.
And you compare it with your previous experience. I mean, you need the experience of having moved other things.
Prior knowledge and prior experience.
I find I tried things out in my mind to see if it fitted with the experience.
An element of, first kind of visualisation or creative thinking around it. What else?
Coming to a group opinion was
very much so, really important. Would it have been easier if you'd done the activity by yourself?
No.
No.
I think science doesn't work if you don't work in a team. You can't be a recluse. You can't live and work in a little chamber. You have to get your stuff out. Other people need to know it. You have to be able to show your work and discuss your work, go to conferences. You have to build collaborations with people that you trust and that trust you. So it is a lot of, it's quite a social endeavor.
What we're going to do now is we're going to take you guys to a mock science conference. Box 2, but there's actually quite a lot of consensus. So we've got wooden cube, small piece of wood, a single block, not metal, and a dice. So that would be kind of our leading theory for what's inside that box. Box number 5. Why did you go for pencil sharpener, and can you convince these guys that that's exactly what's inside it?
Well, I think we can all agree there's one thing inside it. It's pretty small because it takes a fraction of a second to go from one side to the other when you slide it. The pitch, the sound it makes is higher, so that maybe points to it being metallic. So a small, square-ish object, maybe hollow, who knows. Pencil sharpener seems like a good object.
How about our die group?
Pencil sharpener, I would have gone maybe with a plastic one, but it's definitely not the sound of a metallic object. Metallic is much more, it's much sharp, it clings. Whereas that is, in my eyes, it's plastic. I mean, I think it's plastic.
Well, I would like to provide your group with some additional funding in this lovely Science Museum chocolate bar. What I'd ask you to do is to look over your evidence, and for this additional funding, would you be prepared to change your guess to pencil sharpener?
No.
Okay, well that's all right, I shall enjoy this later. Thank you very much. Now, we're not trying to suggest that scientists take bribes in any way, shape or form, but what we're saying is that where your funding comes from can dictate what sort of research you do.
The scientific research is led by a mixture of things. It is a matter of what you're encouraged to work on, what you can get funding to work on. And all the time, my own particular interest and questions kept bringing me back and trying to get funding around those questions, which wasn't always possible. So it was really a mixture of both my own questions and the funding and situations and the questions of other people I worked with then that really led me into certain areas.
Well, what is in the boxes? You know what? I have no idea. And that is the whole point of the activity.
I definitely felt frustrated when I found out we weren't gonna know it was in the box. But my immediate reaction after that was, well, give me a magnet or something so I could do some more tests. Because I bet I can figure out what's in there if you just give me more time.
I was disappointed. I wanted to know how right or wrong we were, and then I thought that's great because that is kind of representative of what science always is. In many things, you really don't know the absolute answer.
It kind of simulates what, at least my job is like, you know, which is just the pleasure of finding things out, you know, and the reason that at least I do science is because of challenges like this.